Ndikulandireni kuphunziro lathu la lero pamene tikupitiriza variations. Pano tili mu lesson 2 ndipo in lesson 2 we are going to cover direct variation. Ndine Cecil Juma tentikale limodzi. Nditamba kale introduce mu lesson 1 apa tingobwerezanso pang'ono then we'll take up and understand kuti kodi tikakamba kuti direct variation timanena kuti chani. Direct variation basically is the relationship between two variables in which one is a constant multiple of the other and one changing according to the other. Okay, so basically you have two variables. Pamakhala zinthu ziwiri zimene umakhala kuzifanizira. Okay, now chinthu chimodzi chimapanga behave mofanana kapena kuti malingana ndi mmene china chikupangira behave. Let's take an example. Let's take for an example. In this case, they're saying if A is directly varied to B, then A and B change accordingly. Okay, A and B change accordingly. And we can as well say that direct variation is the mathematical relationship between two variables in which one variable is a constant multiple of the other. In other words, when one variable changes, the other variable changes in proportion to it. Ngati chinthu chimodzi chikusintha, chinanso chikuyenera kusintha mofanana ndi mmene chinacho chasinthira. Okay, so when we talk of proportional, we mean mofanana ndithu, osasiyana. Ngati china mukutsitsa ndi 5, obviously nayo chikuyenera ndithu chisinthe in that range. Kaya china mukuchikweza ndi 10, china yonse chikamakwera chikwere malingana ndi imene 10. So we'll look at it bwino. So the relationship that describe that is this one. Y is equal to kx. Okay, so y and x can be any variable. You can use any letter, that is. So y and x in this scenario is made with each other variable. But this k is our constant, and this one is this k is the one describing the relationship that is there. Okay, which means if you make k subject of the formula, it will be y over x, and if y over x has to be a constant, okay, regardless of whatever happens to y, regardless of whatever happens to x, this one has to be constant. Constant multiple of the other. Okay, let's say if y is 10 and x, okay, let's do it like this. Let's say y is 10. When I say, what do I mean by that? When y is equal to 10 and x will be equal to 5. So it means our constant in this case will be 10 over 5, which will give us 2. So it means ngati y wakwera kubwera pa 20, x inso akuyeneka kukwera in a way yonena kuti 2 yakhalebe 2 yemweyo. In this case, the x akuyeneka kubwera pa 10. If you divide 20 by 10, you will still remain with 2. Okay, so this relationship is a direct relationship. Okay, something like that. Kaya y wakwera wafika pa 30, ndiye kuti x isakuyeneka akwere Then in this case, I'm going to figure by 15. So if you say 30 divided by 15, it will still give you 2. So that ratio remains constant forever for a direct variation. I hope that makes sense, but it will make more sense as we move on. Okay, let's look at the day-to-day examples. Speed of a car and the distance it travels, an example of direct variation. When the speed is increased, the distance traveled in a given amount of time also increases. Similarly, as the car's speed lowers, the distance covered in that time interval reduces as well. Okay, ngati mwakwera galimoto ngati driver akuthamanga kwambiri, it's very obvious kuti amapanga cover mtunda ochuluka. Koma ngati akuyenda pang'ono-pang'ono, apanganso cover mtunda ochepa. Okay? Tiyelekeze mwapatsa madriver awiri 1 hour kuti ayambe kuyendetsa galimoto 1 hour mofanana anyamukire limodzi. Akamaliza 1 hour yawoyi ayime. Wina ngati akuthamanga kwambiri, it's obvious kuti apanga cover mtunda wautali. Wina ngati akuyenda speed yochepa, it's obvious kuti pa 1 hour apanga cover mtunda ochepa. Something like that. Another example, day-to-day example, we can consider cost of the fruits. It's directly proportional to the weight of the fruits purchased. Masiku ano mashopu ambiri achina Shoprite, achina Sana, achina chani, mukapita kugula zipatso. Amanena kuti amayichika pa scale. Okay? So umalipira malingana ndi mmene chinthu chikulemerera. Ngati chikulemera kwambiri ulipira ndalama zambiri. Ngati chikulemera pang'ono ulipiranso ndalama pang'ono. That is a direct relationship. Tikapita kumudzi amagwiritsa ntchito mbale zoyezera. Pamakuwuzana pali mbale ya tiyelekeze ya 100 kwacha. Basi 100 kwacha sunga this. Pali mbale ya tiyelekeze chimanga kuyeza chimanga. Okay? Pamatokhala ayezera chimanga mkambale. Adzayezera chimanga mwina ka container, adzayezera chimanga mwina mu bigiri, adzayezera chimanga mwina mu ndowa. Okay? Ndi amakuwuzana kuti mbale iyi mwina 1000. Container iyi mwina 2000. Bigiri iyi mwina 5000 or 4000, let's say 4000. Ndowa maybe 8000. Okay, so what it means, the cost of chimanga chikamachuluka, okay, chimanga chikamachuluka mtengo wake so matani umachuluka. Okay, the bigger the container, the higher the price. So that is the direct relationship imene tikukamba apa. Chimodzimodzi ukamagwira ntchito. Okay, ngati wagwira ntchito mahours ambiri, masiku ambiri, kuyenera kulandira ndalama zochulukanso. Okay, so that is a direct relationship. Osati munthu wagwira masiku 10 ndi ukapeza kulandira ndalama zochepa. Okay, so that is a direct relationship. I hope that makes sense, because this background that will help us understand more on what we mean by direct variations. Now let's look at direct variation formula. Direct variation formula connects two numbers by establishing a mathematical relationship in which one variable is a constant multiple of the other. Ndalongosola constant multiple. Okay? This formula is y is equal to kx. That is a direct relationship formula. Okay? So this one, if you make subject of the formula k, it will be y over x. This one remains constant for a direct variation, regardless of the change that is there in y and that is there in x, regardless of their change. But if they remain constant, it means that is a direct variation. Okay, so where x and y are quantities in direct proportion to each other, k is just a constant. K remains a constant for direct variation formula. For things that are directly varies. Hope this makes sense. Let's keep going. Now, let's look at a direct variation graph. In a direct variation relationship, the graph of the equation is the same. Okay, x. If you look at this equation, mbuyo mutumayangana equation of a straight line. Nabangapo how to drive an equation of a straight line. Ndinakuonetsa mmene mutumanena kuti x, k, or timanena kuti y is equal to mx plus c, whereby this one was gradient. It's the same stuff. It's the same stuff with that one, because this one is also line of a straight line. Okay, this one is also line of a straight line. Pamene zikusiyana, it's where it's here. This c is y-intercept. Pamene line yanu ikupanga cut y-intercept. For direct variation relationship, it's whereby this c is 0. The line goes through the origin. So if the line goes through the origin, it means that the relationship of y and the relation of and the x imakhala kuti is directly related. That is if it goes through there. But if this line goes through there, that goes through there, things are different now. Things are different. Okay, so when your straight line on a Cartesian plane passes through 0 or origin, what it means is that that relationship that is there is a direct variation. I hope this makes some sense. To make more sense when we look at an example. Now let's look at how we can solve direct variation. It's the same formula as y is equal to kx, and remember y and x are variables, and k is a proportionality constant. Now you may need to find that proportionality constant. It's simple. You just make it subject of the formula. So it will be y over x. That is y divided by x. Okay, and if you know k, you can either find y or x. Okay, you just replace those values by the figure that you are given. Let's look at this example here, where we are asked to find constant of proportionality, and they are saying x is equal to 69 and y is equal to 23, and the condition is they have a direct variation. Here, when they have a direct variation, we know that the equation for that is y is equal to kx. Okay, remember we have this symbol. That symbol stands for variation. Okay, variation. Okay, yeah. So in this scenario, before this we can as well say represent this equation as y to be represented as y directly related direct varies direct variation. Y and the x are directly variated, which means we can say y is equal to, so here we can introduce the proportionality constant, which is k. Okay, that is when we want to bring equal sign, which means that in this case we have been asked to find constant of proportionality, which is k. Now it will be equal to y divided by x, and if you look at there, y we have been given as 23, that's y, and x we have been given as 69. So 23 into 23, that's 1. 23 into 69, that's 3. So our proportionality constant is 3, or our k is 1 over 3, that is, which means this one remains constant for whatever happens to the variables, has to remain constant for this, say, to still remain as a direct variation. Now we have this example where they're saying y varies directly as x. So they're saying find y when x is equal to 8. Oh, they're saying, yeah, and the y is equal to 72 when x is equal to 8. So in this case, they're saying write a direct variation equation that relates x and y. The first thing is for us to find the equation of direct variation, which can explain what has been explained there, which can cover what has been explained there. Then after that, we are going to use that equation to find the value of x when y is equal to 63. In this case, the first thing to note is an issue of direct variation. So we know that y, the equation of direct variation is equal to y x kx. Okay, remember, direct variation you can see as well say y is directly related to like x. Okay, so for you to bring in the constant of proportionality constant, you bring in equal sign and proportionality constant, and it comes to there. And in this case, they're saying write an equation, so we should write an equation based on those items given there. In this case, we need to find the value of x, of k. So let's find the proportionality constant, which is y divided by x. In this case, y is 72 and x is 8. So 72 divided by 8 is 72. Yeah. 72 divided by 8, that's 9. Yeah, so that's 9, which means your equation is 9x. So that's the equation, right? A direct variation equation that relates x and y. So this is the equation which is relating x and y, which means for you to have y, you need to multiply x 9 times. Okay, something like that. So there's that relationship. Now they're saying using this equation that we have found, find the value, find x when y is equal to 63. So we'll say when y is equal to 63. Okay, so for us is to find the value of x. Okay, so in this case, this is our given found equation as 9x. Okay, y is equal to 9x. So for us to find the value of x, we'll make subject of the formula x. It will be y divided by 9, which is equal to our y we are given as 63. 63 divided by 9 is equal to, in this case, 63 over 9 is 7. That's 7, which means that therefore we can say therefore the value of x will be equal to 7. Yeah, so it's as simple as that. Let's proceed. Yeah, so in these examples, let's look at these examples. Okay, so the distance a jet travels vary directly as the number of hours it flies. Suppose it traveled 3,420 kilometers in 6 hours. write a direct variation equation for the distance from in time t. Okay, so in this, it's an issue of distance and time. Okay, so in this case, we need to have they have told us that the distance varies directly. Okay, distance, yeah, it varies directly to number of hours, in other words time. Okay, so we write distance to be d and the hours, which is time, to be t. So in this case, let's write it in this form. Distance will be equal to, we introduce constant of proportionality, which is k, yeah, like that. Okay, so in this case, this is how we want our equation to look like. Equation of a direct variation. So here they're saying we have been given what we have given. We have been given distance, which is 3420 kilometers, and the time, which is 6 hours. Okay, so the question is to write a direct variation equation of a distance from in time t. So we are given this. So in this case, we want to find the relationship that is there between d and t. So that one is determined mostly by the proportionality constant. So in this case, for us to find k, we make k subject of the formula. So k will be equal to d divided by t. In this case, our d is 3420 over 6. So that one is 3440 divided by 6. That one gives us 570. Okay, 570. So we are going to substitute k into our equation, which means d will be equal to 570 t. So this is our equation, which is direct variation equation for distance d from in time t. So this is our variation equation, that is direct variation equation. Now in this second part, where they're saying the above problem, estimate how many hours it will take for an airplane to fly 6,500 kilometers. Okay, so at first in Auruga 3,420 kilometers. Now tukuti kodi ikuyeneka kuuluka mahours angati kuti iuluke for 6,500 kilometers. Izi ndi zimene amagwiritsa ntchito ma flight. They are able to determine kuti ndege ikanyamuka ku this hour dziko lina likafika nthawi. Yeah, it's like that for decision purposes, also for planning purposes. Kuti uzidziwa ndikunyamuka pano ndikafika pakuti nthawi yakuti. Yeah, so in this case 6,500 kilometers, we are going to use the same equation in many types of kuti. So the equation that we found is d is equal to 570 and t. So in this case, we are given d, which is equal to 6,500 kilometers, and the question is for us to find t, which is time, and the t we know we'll just make the subject of the formula, so it will be t is equal to d over 570, which is equal to 6,500 divided by 570. Let's see, 570. Okay, so this one will be equal to 6,500 divided by 570. Let's put it in a calculator. 6,500 divided by 570. That's 11.4 hours. 11.4 hours. So That's that. For the plane to cover a distance of 6,500 kilometers, it will need 11.4 hours. Okay, so that's that. Let's move on. And here we are saying the mass of each piece of a log. That can be cut because of the piece. And the wood chifuwa is made of the same material. Kagudu kaje ndikufanana. For a certain length, yeah, kagudu kaje ndikufanana. So a piece 30 centimeter long has a mass of 2 kg. What will be the mass of a 45 centimeter long log of wood? Okay, so in this case I would also put the 30 centimeter. Mukadulapo 30 centimeter pachitengo chimenecho, weight yake is 2 kg. Mukazadulanso, that's mass yake. Mukazadulanso 45 centimeters, akufuna tiuze tipeze kuti mass yake izakhala bwanji. So in this case the relationship is a direct proportional relationship, which means it's a direct variation. Yeah, so remember direct variation, the equation is y is equal to kx. Okay, in this scenario we are using mass and length. So instead of using y is equal to kx, it will be m will be equal to k, in this case L. Okay, y is proportional to L, just like that. In this case we are given mass, which is 2 kgs. We are also given length, which is 30 centimeters. Okay, in this case you can find k, which will be m over l, which is m is 2 over 30, which is 1 over 15. Okay, that's k, which means our equation which relates mass and length will be equal to m is equal to 1 over 15 L. Okay, so the question is what will be the mass of the 45 centimeter length? Therefore, for the 5 centimeter long log of wood, the mass will be m 1 over 15. So this is L, 45. So 15 1, 15 to 45 3, which means 3 kgs. Okay, so that's your mass for a 5 centimeter long log. And we have this one. In this case, the author is also to sketch a graph of the relationship P Q. Okay, in this case, the same P is directly proportional to Q, or directly varies, P directly varies with Q, and P is 20, Q is 100. Find the relationship between P and Q. So that's the first thing. The relationship, we know that P to Q, this one can be written as P is equal to constant Q. Introduce equals, you put constant, it's equal to Q. Then K will be equal to P over Q. And in this case, our P is 20, our Q is 100. So that's 1 over 5, which means the relationship is P will be equal to 1 over 5Q. Okay, then find the relationship, that's the relationship. Then that's saying we should do sketch a graph of this relationship. Okay, so in this case you have to know which one is your independent variable, which one is your dependent variable. So in this case, this is dependent, that one is independent. All right, so regarding this form of equation, which means this is independent, this is dependent. That's why. Yeah, so let's put up table of values. In this case, Q, and that's P. Okay, if we have to go by that. So let's say what could be our values. Let's say 0, 0. Let's say 5, 10, 15, 20, just to make sure that we don't have fractions. Okay, if it is 0, P in the Kalajani, across 0. If it is 5, P will be equal to 1. If it is 10, to get 10 apple divided by 5, 2, like that. 15 divided by 3, 20, equal 4. So you put a sketch. In this case, this is your P and this is your Q. So you have 0. This is 5. This is 10. This is 15. This is 20. It's just a sketch. Okay, 3, 4. So that's 1, 2, 3, 4. Okay, so when 0, 0, that's 0.0. Okay, when 5, there 1, it's 1. When 10, there 2. So these ones are meeting here, somewhere there. When you're 15, you go there, meeting here. Okay, when you're 20, okay, they're meeting there. So that's your Stradon equation. Remember, we said that for a direct proportional, the line passes through the origin. That's the mx plus c form of equation. Okay, so in this case, c y-intercept amakala 0, so it becomes that one only. So this is the form which is direct variation. Okay, direct variation relationship. And this m is the same as to say gradient. So if you are given a graph like this one, you can as well find gradient and come up with this relationship. Okay, come up with that relationship, because the gradient is changing y divided by changing x. Okay, if you see here changing y is 1, there, here changing y is 5. So changing y 1 over 5. You see this one is equal to, here it's gradient, but here is k. Okay, so those are the relationship that are there. So I think quite a lot to see about in this video. See you again in the next video. Thank you.